So we know that if we have a linear regression model with heteroscedasticity, then the OLS estimator is still unbiased and consistent, but unfortunately the same cannot be said for these standard errors. So the implication will be that with heteroscedasticity, inference is just not going to be correct, not even asymptotically. So this lecture will discuss a method that will allow us to get correct inference asymptotically. And it's based on something called robust standard errors, or sometimes called White's standard errors. The setup for this lecture is as follows. We have a linear regression model with random sampling looking like this. It's linear in parameters, doesn't have to be linear in data. All the explanatory variables are exogenous, but the error terms are heteroscedastic. Perhaps we know this, or perhaps we suspect it from performing a test for homoscedasticity, which perhaps was rejected. So as just mentioned, OLS, unbiased consistent, standard errors are inconsistent. So it turns out that there is an alternative to the Gauss-Markov variance formula, which will then give us an alternative standard error. And it's possible to show that these standard errors are consistent even under heteroscedasticity. So in Gretel, here is the simple linear regression model using OLS. The coefficients, unbiased and consistent, the standard errors not consistent. So if we now have heteroscedasticity, what we can do instead is the following. I run consumption on GDP and I check this box, robust standard errors. If I click OK now, then these standard errors are actually consistent. We can see here heteroscedasticity, robust standard errors. And that means that I can trust these numbers and these numbers, at least asymptotically. That is, at least when n is pretty large. Here n is 154, which we typically consider as fairly large. So robust standard errors, also called White adjusted standard error, these are consistent even under heteroscedasticity. If I base my inference on these standard errors instead, then it will be approximately correct if n is large. We're not going to discuss in this lecture the details behind figuring out robust standard errors. There are actually a couple of ways of doing it, and you definitely need matrix notation to talk more about the robust standard errors. If you want to get robust standard errors in eViews, you need to go to the options folder, and then you go here, coefficient, covariance method, you go Huber-White, and that will give you robust standard errors. You can see that the method that we used in eViews will give us exactly the same standard errors as the HC1 in Gretel. So in summary, this is the simple way of handling heteroscedasticity. We continue to use the OLS estimators even though they are not efficient. They are consistent and unbiased, so that's fine. And we have adjusted the standard errors so that they are consistent as well. And that means that at least asymptotically, all our results will be okay. But bear in mind that these estimates of the coefficients calculated using OLS are not efficient. That means that there is a way of actually coming up with better estimates. And this method is based on something called weighted least squares, which we will discuss in another lecture.